400 million years ago, long before the age of the dinosaurs and even before most life had made its way onto land, planet Earth was a very different place. The continents we know today were arranged in shapes that no map would recognize. A vast supercontinent called Gondwana covered much of the southern hemisphere, while the land that would one day become North America, Europe, and Scandinavia sat clustered together near the tropical equator. Between these landmasses stretched enormous shallow seas, warm and sun-soaked, no more than a few hundred meters deep in most places. The land around them was almost completely bare. A few low-growing plants had only recently begun to creep away from the water's edge, and the only animals that had tested dry land were small invertebrates, nothing larger than an insect. The real world, the world that mattered, was entirely underwater. And in that underwater world, the rules were completely different from anything we know today. There were no sharks as we would recognize them. No whales, no dolphins, no large fish to speak of. The fish that did exist were small, jawless, encased in bony armor, and vastly outnumbered by invertebrates in every habitat they occupied. What ruled the shallow seas, the estuaries, the warm tropical coastlines, and even the open ocean was something else entirely. Something that looked, to our eyes, like a nightmare version of a scorpion, except bigger than any scorpion that has ever lived, bigger than most things that have ever crawled, swum, or walked across this planet. They were called Eurypterids, and they are more commonly known as sea scorpions. Some of them were small enough to hold in your hand. Others grew to the size of a car, and for more than 200 million years, a time span longer than the entire age of the dinosaurs, they were the dominant predators in most of the world's oceans. If you were to somehow find yourself standing at the edge of one of those ancient Silurian seas around 430 million years ago, the first thing you would likely notice is how different the water looks. The color would be there, the clear blue-green of a shallow tropical sea, but the life in it would be entirely unfamiliar. Looking down through the surface, you would see the seafloor carpeted in creatures that are almost completely extinct today. Trilobites, hard-shelled arthropods that look a little like giant woodlice, would be scuttling across the sediment in enormous numbers. Nautiloids, the ancient ancestors of the modern nautilus, would be drifting through the water column in extraordinary variety, some of them growing longer than a man is tall. Ancient corals, shaped like elongated cones rather than the branching structures we know today, would be rising from the sea floor in isolated columns. And if you looked more carefully into the shallows, you would start to notice something else: shapes moving along the bottom. Broad, flat, segmented bodies propelled by multiple pairs of legs, with wide paddle-like appendages at the rear, sweeping them forward or upward. Some of them would be small, perhaps the size of your forearm. Others, moving in the deeper water further out, would be considerably larger. These are the sea scorpions, and the more time you spent watching them, the more unsettled you would become. The most common sea scorpion you would encounter in those ancient Silurian seas is one called Eurypterus remipes, which happens to be the official state fossil of New York State. Its fossils are so abundant in certain rock formations in western New York and Ontario that paleontologists have found them by the thousands. In fact, of all the Eurypterid specimens ever recovered from the fossil record worldwide, more than 90% belong to this genus alone. Eurypterus was essentially the sparrow of its ecosystem, not the largest or most fearsome species, but enormously successful and widespread across every coastal environment it could reach. Eurypterus typically reached about 20 to 30 centimeters in length, roughly the size of a large lobster. It had a broad, shield-shaped head section covered in a tough exoskeleton, two compound eyes sitting on the upper surface looking outward, and a segmented body trailing back to a blade-shaped tail. At the front, a pair of small claws called chelicerae worked food into its mouth, while up to 6 pairs of appendages, some for walking, one flattened pair for swimming, allowed it to move equally well across the seafloor and through the water above. It hunted small invertebrates and scavenged whatever it could find, using ambush and opportunism in equal measure. But here is something surprising about the enormous number of Eurypterus fossils we have found. Most of them are not dead animals. Most of them are empty skins, the shed exoskeletons left behind when Eurypterus molted, growing a new and larger shell to replace the one it had outgrown. Like all arthropods, sea scorpions could not grow continuously inside a rigid shell. They had to shed it periodically, expand rapidly while the new one was still soft, and then wait for it to harden at a larger size. These mass molting events, preserved in dense layers in the ancient dolomite rock, give us an extraordinary window into living populations of animals that died out 250 million years ago. Eurypterus was not the creature that would shake the ancient ocean, but it was not the only sea scorpion in those waters. Far from it. While Eurypterus was the most common sea scorpion in the Silurian seas, another species was operating on an entirely different predatory philosophy. You would not want to stumble across this one in the shallows. It is called Mixopterus chiaeri, and it was built less like a swimmer and more like a living trap. Mixopterus reached about 75 centimeters in length, which is roughly the size of a medium-sized dog, and its body plan was unlike anything we see in modern arthropods. Its 4 rear legs were used for walking along the seafloor, but its 2 front pairs of appendages were something else entirely. These had been heavily modified into enormous, spine-covered weapons, long, rigid, and capable of closing together with tremendous force, interlocking like the teeth of a steel trap. And at the very back of its body, a curved tail spine could be driven forward between those clasped arms, stabbing into whatever they had already captured. Scientists believe that Mixopterus was an ambush predator that spent much of its time buried in the soft sediment of the seafloor, with only its forward-facing eyes and raised predatory arms visible above the substrate. It would wait, sometimes for a very long time, for something to wander within range. When that happened, the arms would snap shut in a fraction of a second. The prey had almost no chance. We know that Mixopterus occasionally came onto land as well because its fossilized footprints have been found in ancient rock formations in Ringerike, Norway, preserved in sediment that was once a tropical coastal mudflat. 3 sets of walking leg impressions and a drag mark from the tail along the center line, the signature of something hauling itself along a beach and then returning to the water. 400 million years ago, something that looked very much like a giant armored scorpion was crawling across a shoreline that would one day be part of Norway. But as formidable as Mixopterus was, it was not the most aggressive sea scorpion in the fossil record. To find that, we need to go back even further, not just in the history of sea scorpions, but in the history of the planet itself. The Ordovician period, which preceded the Silurian, was the era in which the sea scorpions first truly established themselves as apex predators of the marine world. And one species in particular from that time, known as Jaekelopterus ohioensis, provides some of the most dramatic evidence of just how brutal life in the ancient ocean actually was. Jaekelopterus reached about 1 meter in length and was heavily armored with spiny grappling appendages at the front of its body designed to seize and hold prey. Its fossils have been found in Ordovician rock formations in Ohio. What made paleontologists stop in their tracks when examining these fossils was what they found alongside them. Scientists discovered fossilized digestive remains, technically called coprolites, associated with Jaekelopterus specimens, and when they examined the contents, they found fragments of trilobites, fragments of jawless fish, and fragments of smaller Jaekelopterus individuals. The same species. Jaekelopterus was a cannibal, preying on members of its own kind, confirmed in the fossil record at 467 million years ago. This tells us something important about the nature of life in these ancient seas. These were not gentle, slow-moving bottom feeders. From their very earliest appearance in the fossil record, sea scorpions were aggressive, territorial, and entirely opportunistic. If something was smaller and within reach, it was prey, regardless of what species it belonged to. Now, while Mixopterus lurked in the shallows and Megalograptus prowled the Ordovician seafloor, another branch of the sea scorpion family was mastering something very different: speed, range, and the open ocean. This lineage, known as the Pterigotids, produced some of the largest and most formidable predators of the Silurian and Devonian periods, and the most famous of them is called Pterigotus. Pterigotus was built for hunting in open water. Its body was flattened and streamlined, with a broad paddle-shaped tail that acted as both rudder and propeller. Its eyes were large, forward-facing, and capable of stereoscopic vision, meaning it could judge distances accurately, the same way an eagle or a hawk can today. Paleontologists have actually measured the visual acuity of Pterigotus eyes from preserved fossil specimens, and the results place its eyesight in the same category as modern active predatory arthropods. It was watching you long before you knew it was there. At the front of its body, the Jaekelopterus, those first pair of appendages that in Eurypterus were small and used for handling food, had been completely transformed. In Pterigotus, they were long, heavily toothed, and capable of extending outward with considerable reach, designed not for grappling, but for seizing and immediately slicing. Think of them less like claws and more like a pair of scissors the length of your forearm, operated by something that weighed as much as a large dog and was moving toward you at speed. Pterigotus commonly grew to around 1.5 to 1.7 meters in length, about the height of an average person. But what is perhaps most impressive about this creature is not its size, but its range. Of all the sea scorpion species known to science, only the Pterigotid lineage managed to spread across the entire planet. Fossil specimens of Pterigotus have been found in Scotland, eastern North America, Scandinavia, the Czech Republic, and Australia. During a period when most marine animals were confined to local coastlines and shallow regional seas, Pterigotus was crossing open oceans and colonizing every warm, shallow sea on Earth. For roughly 37 million years, the pterigotid sea scorpions were the top predators in nearly every aquatic habitat on the planet. And yet, as large and as widespread as Pterigotus was, it was not the biggest of its kind. Not even close. To find the largest sea scorpion that ever lived, the largest arthropod that has ever existed on this planet, we need to move into the early Devonian period, around 390 million years ago. And we need to go to a quarry near a small town in western Germany. In the early 2000s, a paleontologist named Markus Poschmann was working through rock formations near the town of Prüm in the Rhineland region of Germany when he found something unusual. It was a single fossilized claw, technically called a chelicera, measuring 46 centimeters from base to tip. That is roughly the length of your entire forearm from elbow to fingertip, and it was serrated on its inner edge, with dozens of small teeth running along it. Poschmann recognized the species it belonged to, Jaekelopterus rhenaniae, a sea scorpion previously known only from smaller and more fragmentary remains. He contacted his colleague Simon Brady at the University of Bristol, and together they worked out what a claw that size actually meant. In the pterigotid sea scorpions, claw length is proportional to body length in a consistent and predictable way established from multiple specimens. If Jaekelopterus followed the same proportions, and there was every reason to believe it did, then the animal this claw belonged to would have been approximately 2.5 meters long, not including the claws themselves. Including the full extension of those claws, the functional length from the tips of its arms to the end of its tail may have been closer to 3.5 meters. That is longer than a standard car. Brady and Poschmann published their findings in the scientific journal Biology Letters in 2008. The conclusion was definitive. Jaekelopterus rhenaniae was the largest arthropod ever to have evolved on Earth. Not the largest sea scorpion, not the largest chelicerate, the largest arthropod in the entire fossil record, across all of geological time, bigger than any spider, any crab, any lobster, any insect or millipede that has ever existed anywhere on this planet. To put this in perspective, the largest arthropod alive today is the Japanese spider crab, which can reach a leg span of around 3.7 meters, but its body is only about 37 centimeters wide, and it weighs just 2 kilograms. Jaekelopterus would have dwarfed it entirely. With an estimated body weight of up to 100 kilograms, Jaekelopterus was a genuinely massive animal by any standard, a top predator that had no serious competition in its environment. Its vision improved as it aged. Studies of its fossilized compound eyes show that younger, smaller individuals had relatively lower visual acuity, while the large adults had eyesight comparable to modern predatory arthropods. This suggests that as Jaekelopterus grew, it moved into progressively deeper and darker water, where sharp vision became increasingly important for locating prey. What it was hunting in those depths is not entirely certain, but the evidence from associated fossil sites points to other large Eurypterids, armoured fish, and anything else that moved slowly enough to be caught by something the size of Jaekelopterus. However, Jaekelopterus was not alone in the Devonian Ocean. The world it lived in was extraordinary in its own right, and understanding that world helps explain how something this large was possible in the first place. During the Silurian and Devonian periods, oxygen levels in the atmosphere were significantly higher than today, perhaps as high as 25 to 35% compared to our current 21%. This high oxygen environment dissolved into the warm, shallow seas and provided the metabolic fuel that large, active invertebrates needed to power their enormous bodies. It created, essentially, the conditions for a brief window in Earth's history when arthropods, animals built around an external shell rather than an internal skeleton, could achieve sizes that have never been reached before or since. The Devonian Ocean was also teeming with prey. Giant nautiloids still cruised the water column. Trilobites carpeted the seafloor. Early armored fish were becoming more common, though they were still small and heavily outgunned by the Eurypterids. The shallow seas were warm, productive, and rich in food at every level of the water column. For a predator as capable as Jaekelopterus, this was essentially an all-you-can-eat environment with very few threats and almost no competition. But the fish were watching. Vertebrates, animals with internal skeletons, with spinal cords, with the body plan that would eventually produce every creature from a salmon to a human being, had existed in the oceans since the Ordovician period. But for a very long time, they remained small, armored, and marginal. The sea scorpions dominated the water column, and the fish could do little about it. However, as the Devonian progressed, the fish began to evolve at a remarkable pace. They developed jaws, a feature so significant that the jawed fish, known as gnathostomes, are classified entirely separately from the jawless fish that preceded them. Their jaws grew stronger. Their bodies grew faster and more maneuverable. Their armor became more effective. Some paleontologists now believe that this rapid evolution of the vertebrates was driven in part by the presence of the sea scorpions. In other words, the Eurypterids were the pressure that forced the fish to improve. Generation after generation, the fish that survived were the ones that were a little faster, a little more agile, a little harder to catch or to crack open. And that selection pressure, applied across tens of millions of years of evolution, produced animals that were increasingly competitive with their giant arthropod hunters. Eventually, the fish became good enough to start pushing back. As jawed fish grew larger and more powerful through the Devonian period, many sea scorpions began retreating from the open marine environment into estuaries, rivers, and lakes, where fish diversity was lower and the sea scorpions could still maintain dominance. This is actually why Jaekelopterus, despite being called a sea scorpion, was most likely living in brackish to freshwater river delta environments rather than open sea. The open ocean was becoming increasingly dangerous for them. By the late Devonian, around 374 million years ago, a series of extinction events began to strike the marine world with enormous force. Reef systems collapsed. The warm, shallow seas that had sustained sea scorpion diversity for 100 million years began to change rapidly, cooling and losing oxygen in ways that devastated the most specialized and largest species first. The great pterygotid lineages, Pterygotus, Jaekelopterus, and their relatives, disappeared from the fossil record. What remained were smaller, more generalized sea scorpions that retreated into freshwater habitats and clung on for another 120 million years, slowly declining in both size and diversity as fish continued to dominate every aquatic environment they had once controlled. The last sea scorpions died around 251.9 million years ago, during the end Permian mass extinction, the most severe extinction event in the history of animal life, which eliminated approximately 90% of all marine species and 70% of all land animals. Not a single sea scorpion lineage survived it. After more than 220 million years, as one of the most successful predatory groups in the history of the planet, they were gone entirely. And the fish, which the sea scorpions had hunted for so long, inherited the ocean. But here is something worth thinking about. The sea scorpions did not die out without leaving something behind. Not a direct descendant. No living animal today is directly descended from a Eurypterid. But the pressure they exerted on the vertebrates around them helped shape the evolution of our own ancestors. The fish that survived the age of sea scorpions were faster, more agile, and better sighted than the fish that had come before them. Those fish eventually evolved into the first four-limbed land animals, the tetrapods, and those tetrapods are the ancestors of every reptile, bird, mammal, and human being alive today. In a very real sense, the existence of the sea scorpions and the evolutionary pressure they placed on early vertebrates is part of the reason we exist in the form we do. Additionally, the sea scorpions left something more tangible behind. Their closest living relatives are the arachnids, spiders, scorpions, mites, and ticks, along with the horseshoe crabs, which are among the oldest unchanged animals on the planet and have barely evolved in 450 million years. Modern scorpions in particular are thought to have evolved from sea scorpion-like ancestors that made the transition from water to land during the Silurian and Devonian periods. So the next time you encounter a scorpion, you are looking at a distant relative of the largest predatory arthropod that has ever lived. It is also worth noting that the remarkable fossils of sea scorpions are found almost worldwide. New York State has some of the finest and most abundant Eurypterid fossils on the planet, preserved in the ancient dolomite rock of the Bertie Group Formation in the western part of the state, so numerous and so well preserved that Eurypterus remipes became New York's official state fossil. Specimens have also been found in Scotland, Estonia, Norway, Germany, the Czech Republic, and Australia, reflecting just how widespread and successful these animals were during their long reign. In some formations, the fossils are so densely packed that entire beds of rock are almost nothing but shed sea scorpion skins, the preserved record of mass molting events that happened at the edges of ancient tropical seas hundreds of millions of years ago. The ocean of 400 million years ago was a genuinely terrifying place by our standards. Not because it was more violent or more dangerous than the oceans we know today, but because the creatures that ruled it were so utterly different from anything alive now, and so much larger than we tend to imagine when we think about the distant past. We tend to think of ancient seas as places full of trilobites and primitive fish, slow, small, not particularly threatening. But the reality is that those same seas were patrolled by animals the size of cars, armed with claws the length of your forearm, with compound eyes sharp enough to track a moving target through murky water, and with 220 million years of predatory experience behind their lineage. The giant sea scorpions were not a footnote in evolutionary history. They were one of the longest reigning and most widespread predatory groups that has ever existed on this planet. And the ocean they left behind, changed, reshaped by the fish they helped to evolve, is the ocean that eventually gave rise to every form of marine life we know today. Please let us know in the comments what you thought about this video and tell us what you'd like to see us cover next. If you enjoyed learning about the prehistoric ocean, check out our other videos on ancient life for more. Stay tuned for more videos, and thanks for watching.